Hi everyone. In this video lecture series, next we are going to see about rectifiers. Before going to the rectifiers, what do you mean by rectifiers? Rectifier. So far we have seen what are the topics we have seen. We have seen as so many topics. So first one is PN junction diode, PN junction diode. Next, we have seen Zener diode. Next topic is, so the application of PF, one of the application of PN junction, it is rectifier. So for in rectifier is mainly used to convert AC supply to DC supply. So main thing of rectifier is converting AC supply to DC supply. So let's see how the AC supply is converted to DC supply. What are the process involved in converting AC supply to DC supply? So what do you mean by rectifier? Rectifier is an electrical device that converts alternating current into the direct current. Here this process called as rectification process. So this is the general block diagram of conversion of AC supply to DC supply. First thing is transformer. So input AC voltage, transformer, and a bridge rectifier, and we have filters and we have regulators. So when the AC supply is given as an input to transformer, the transformer, the signal, we can see the supply, AC supply is given to the transformer. Here we are using step down transformer, which step downs the input voltages, and this step down the voltages next it is given as input to the bridge rectifier. In this bridge rectifier, it rectifies as an unidirectional or bidirectional based on the what type of rectifier we have used, whether we have used single phase, half wave rectifier or full wave rectifier. Based on that, we are getting output as half wave rectifier, full wave rectifier. This output is then given to the filters. In this filters, we are filtering that peak voltages, and finally this half wave rectifier we are filtering by using of the capacitor, and finally we are giving to the voltage regulator, and it regulates the final output voltages. Final output voltages are DC voltages. Here the input is AC supply and the output is DC supply. This is the rectifier, is the process of converting AC supply to DC supply. Okay. Here, before going to see the voltages, here what and all we have used. Here we have already used the supply voltages, AC supply, and we have used a transformer. So transformer, here we used as step down transformer, and here we used one diode, and finally we have used one resistor load. Okay, this is supply, this is what step down transformer, this is diode, and this load resistor. Here we are connecting CRO across this load resistor. Okay, now what happens here? First, the AC supply is moved to the step transformer. This transformer is step down transformer. So here we are giving the supply, AC supply, and the output of this step down transformer is step down to 24 volt, step down to 24 volt for an example. And this positive supply moves to the diode. This diode, now the positive supply is connected with the anode side of the diode, and this is the cathode side of the diode. The positive supply is connected to the anode, and it, now this diode act as an forward bias, and the current allows flows and finally closes this. While seeing in the CRO, we'll be getting the positive half cycle. In the CRO, we are getting the positive half cycle. Now what happens? Next thing is reverse bias. Okay, next. Now next is negative half cycle. Now this anode is connected with the negative half cycle. What happens? So anode is connected with the negative half cycle. Now this diode is in reverse bias. Now this diode is in reverse bias. And now what happens here? So it is, this diode is in off condition. Now we are checking this waveform across the CRO. We won't be getting any waveforms. And finally, next cycle is in positive half cycle, and that this positive is connected with anode, and now this diode is in on condition, and finally we will get the waveform. So this is what the output we are getting. This is what the output we are getting: output voltage and output current. This is what half-wave rectifier. This is what half-wave rectifier. This we are going to see in this upcoming part. See, we have two parts. One is half-wave rectifier and full-wave rectifier. Now, what is half-wave rectifier? This is the negative. Here we can see the animation video, small animation video. Here the what happens is, so we have already seen this AC supply, the step down transformer and diode and load. So the input is, so the input supply AC supply 230 volt AC supply step down, and we are given across to the load, and finally we are getting half cycles. We are getting only positive half cycles. Here voltage, this is what, here we having the diode. Here we say, so positive half cycles, where we can see that now the diode is in, from negative cycle, the diode is reverse bias, and the flow of electrons is stopped here. And finally, in this, we are not, we are getting zero output. Now it is in positive half cycle, that we are getting the positive half cycle output. Now the reverse bias diode is an open circuit, and we won't be getting the waveform. Now when the diode is in positive, now the forward bias, the diode is in a closed circuit, and now we are getting the output. Okay, this is what half-wave rectifier. Here half-wave rectifier, see, let's see that half-wave rectifier, we are getting the waveform. Now it is, now this after zero crossing, it moves to the negative half cycle. The diode will be an open circuit, and we won't be getting any waveform in the output. Okay, here we can see the advantages, and the half-wave rectifier circuit is very simple and low cost. And the disadvantages is, so where the pulsating output and frequency is equal to the supply, and so filtering is needed. So it is now here the filtering is needed. This is the main disadvantages. And the AC supply delivered power during half cycle only, as so output is low. So we are getting only half cycle. The output we are getting only one half cycle, positive half cycle, and remaining half cycle the output is zero. This is not completely as a pulsating DC. Here the output frequency output is equal to frequency input. The output frequency equal to output input frequency is equal to output frequency. Here the small MCQs. The efficiency of half-wave rectifier is 40%. Small animation video.
The rectifier consists of diodes. A diode is a semiconductor device which allows current to flow through it, but in only one direction. So if we connect this lamp to a DC power supply, it will illuminate. We can reverse the leads and it will still illuminate. If I place a diode on the red wire and connect this to the positive, it will again illuminate. We can therefore,
here we can see,
if we look at an AC supply with a step-down transformer, which simply reduces the resistor, the lamp, the motor, etc. If we inserted a diode, the diode will only allow current to flow in one direction.
Diode
so
current flows.
Our experiences pulsating waveform. The negative half of the sine wave is currently being blocked. Therefore, a half-wave rectifier.
See, negative half cycle. This is the positive half cycle during negative half cycle.